Hello, I'm Logan Ince, and this is Team 2980's Week 1 Robot Update video. This week, we got our challenge, and broke into 4 subsystem design groups to tackle different elements of the robot design in relation to Destination Deep Space. After a few days of designing all the best subsystems we could come up with, we reshuffled our teams into 3 robot design groups, selecting from the subsystems that we had already designed in order to make a robot that we thought would best tackle the challenge. At the end of a few days, we presented these robots to the community. The robots being named Albert the Seventh, Cheese Wedge, and Cameron.
Hello, my name is Marcus Carmen, and I'm the design lead of the group that came up with the robot Cameron. So the drivetrain we chose for Cameron was the Raptor Trax, which is an upgraded version of the Rhino Treads, which were released on Andy Mark 3 years ago. It's being driven by 2 mini sims into a Toughbox Mini on either side. So the climbing mechanism that we chose for Cameron was 2 double 4 bars mounted in our drivetrain that would push up off of the ground and lift us up onto the 3rd habitation zone in the end of the match. Alright, so the manipulator for Cameron would be mounted on an elevator and a linear actuator, so we'd be able to lift up to the highest goal, and it would be 2 pieces of PVC pipe cut in half lengthwise, and the linear actuator would allow it to open up and close. So it would be able to grab onto the balls just by driving up to them and grabbing a hold of them, and then it would be able to grab onto the gears by driving into the center and opening it up. One important thing with this though is we wouldn't be able to ground load, we'd only be able to grab things off of the loading station at the end of the field.
I'm Taylor, and I was on the Cheese Wedge design team. The primary system of our robot was a ramp that took up the upper level of our robot, and it was split into 2 sections with a gap in the middle for room for other subsystems. Each ramp had a panel on top of it that would slide down so that the robot we were assisting could easily climb to the upper level of the hab. For our scoring mechanism, we used the same subsystem as the Cameron design group. However, ours was limited by the ramp, so it couldn't extend as far out to the side to grab the balls and could only do the hatch covers. Ours could only complete the first level of the rocket but could do all of the cargo ship panels. We believe that this would be a good trade-off for having the ramp, since the ramp would give us 12 points and a ranking point, whereas completing upper levels of the rocket wasn't assured and wouldn't give us as many points. Our design team chose the kit of parts drivetrain with the 6-wheel drive and 6-inch wheels configuration, and we believe that this would be the best option since we already had it assembled and had multiple copies of it and worked with it in the past, and we knew it to be reliable. Because we already had a copy of it, we knew it would cost $0 and we wouldn't have to wait for shipping, whereas for the Raptor tank drive, we would have to wait for it to arrive and it would probably be back ordered.
Hello, I'm Nick Baez. I was one of the leaders of the group Albert the Seventh. Our design wanted a robot to be aimed towards being somewhat of a jack of all trades and to be a appeasable aligned selection partner. So for our drive base, we wanted to do a West Coast drivetrain. This would be as fast or faster than the kit of parts drivetrain the other 2 groups were using. This would also be a lot more stable. There would be a lot less wobbling that the kit of parts had, especially from last year's robot. The reason we wanted to use a West Coast was mainly because Beetle, the first robot that we took to Worlds, had that drivetrain. It was very fast, reliable, and we didn't have to do a lot of repairs on it. And a lot of the parts are very durable compared to kit of parts, I would argue. The only problem is the parts aren't available on Andy Mark for the most part anymore. So if we were to go with that drivetrain, it wouldn't necessarily be easy to track down the parts, and we'd most likely have to manufacture them on our own. So for a hatch loading system, we want to take a step off of Robot in 3 Days. They did a hatch loader where they had Velcro on it. We want to do that. and then we would dispense it through pistons. Pretty simple system, and it worked very effectively, fast cycle times and such. And then for our cargo, we want to do a fixed shooter. This is a controversial thing, but we wanted to look past it because the reason it was controversial is the accuracy. But if we did a fixed shooter, it would just be facing one direction in one angle, and it would be fairly accurate most of the time. So for our climbing system, we want to reach level 2 or 3 by a linear slide located in the back side of the robot that would lift up the robot, and the front wheels would roll towards the platform, and the friction would end up having our robot go up towards the platform. And this had expansion for robot assist. So overall, it was a system our whole group agreed on.
In our final design, we will be using the Climber from Cameron, the kit of parts drivetrain and dual camera system from Cheese Wedge, and last but not least, we will be using the hatch placer and the cargo intake from Albert Set.
Thank you for watching this week's Robot Update video. See you next week, and don't forget to click below to like and subscribe.